is tangent, we got tangent cubed. So you got tangent cubed x. Uh-oh, you can't see it. Sorry about that. Tangent cubed x is equal to tangent x. This is similar. This is very, very similar to the problem we just did. All right, very similar to the problem we just did. Rather than go off to the side like I've done in the last two problems, I'm not going to do that. I'm just going to proceed with the problem. You'd have to subtract. Tangent x on both sides. You get tangent cubed x minus tangent x is 0. All right. So now you would factor out the tangent. You get tangent x times tangent squared x minus 1 is 0. All right. So now you'd set the tangent x equal to 0. You'd set tangent squared x minus 1 is 0. All right. And then you'd end up with, like I've said previously in previous problems, you'd have to go off to the side. I'd ask my students not to require a calculator on this problem. Where is tangent x is equal to 0? You can get that from the tangent graph. This is the third graph that we've drawn. We've drawn the first problem, we drew the sine graph. The second problem, we drew the cosine graph. And this final problem, we're drawing the tangent graph. So this is pi. This is 2 pi. The tangent graph looks something like this. All right? The tangent graph looks something like this. All right? So the tangent of which of these angles is 0? The tangent of the tangent of what angle is 0? I'd ask my students to be able to see that the tangent of 0 is 0. X is 0. Here, this curve goes through the y value 0. This curve also goes through the y value 0 at pi. So your answers will be 0 and pi. All right? Well, and 2 pi, but we'll just say 0 and pi for right now. All right? So that would be their answer in radians. If I ask my students to write the answer in degrees, they would say that the answer is 0 and 180 degrees. Again, I only have two answers here. I've just written both answers in different ways. This is 0 radians, pi radians, 0 degrees, 180 degrees. These answers are exactly the same. I just written them in two different ways. Now, what I'd like to show you is the reason why I wanted to do this problem is because this problem could be a problem in and of itself. I could ask my students, this could be the beginning of the problem. All right, so for this particular problem, it's sort of a part of the problem, but this could be the beginning of a problem on my students, on the final exam that my students will be taking, in some cases, next week. So here, they'd have to add 1 to both sides. You get tangent squared x. Tangent squared x is equal to 1. All right. So now I'd ask my students to take the square root of both sides. And you get tangent x is equal to, and this is where a lot of my students make a common mistake. The second degree equation, you're going to get plus or minus. There are two answers there, plus or minus 1. If they only put 1 there, they won't get as many solutions as I want them to get. All right. They won't get as many solutions as there are to the problem, I should say. All right. So now we'll take this in steps. Where is tangent x positive 1? All right. So you go off to the side. You set up a coordinate axis here. Where is tangent positive? Well, all students take calculus. Tangent is positive in the first quadrant. Tangent is positive in the third quadrant. All right, so now you'd also need a reference angle. All right, so you'd have to have studied that a 1-to-1 ratio could produce, and in fact does produce, the legs on a special triangle. So you establish some value x, and the tangent by definition is the opposite over adjacent. This is 1 over 1, so the opposite is 1, the adjacent is 1, and I'd expect my students to know that this produces a 45-degree angle. So the reference angle is 45 degrees, or another way to say 45 degrees is pi over 4 radians. Pi over 4 radians. All right? So your answers are going to be pi over 4. So in addition to 0 and pi, in addition to 0 and pi, let me put my answers here. I have a little bit more space. In addition to 0 and pi, which came from tangent x is 0, you'll also have pi over 4, and you'll also have, this is 4 pi over 4, and then this is our answer. If this is 4 pi over 4, and that's our answer, the answer you're looking for would be 5 pi over 4. All right? 5 pi over 4. It turns out that you're still not done. Now, my students who would have forgotten that this is plus or minus 1, they would have stopped there, because they would have established the answers where tangent is positive to be in the first and third quadrant. However, they should remember that the tangent for this particular problem can be negative as well. Tangent of x can be negative as well. And tangent is negative in the second and fourth quadrants. So you put a pi over 4 here, pi over 4 here, and you'd get 2 additional solutions. So here, this is 4 pi over 4, but that's our answer. This is our answer, this angle right here. This is 4 pi over 4. You subtract pi over 4, you're going to get 3 pi over 4. All right? That's your fifth answer. And then you end up, this is 8 pi over 4. This is 2 pi, or 8 pi over 4. You go back pi over 4. Your sixth answer would be 7 pi over 4. All right? So I didn't write this answer in degrees. I'm just not going to write this in degrees, but these would be your answers in radians. All right? So that's about all we have time for that particular problem. So you got 6 answers. All right? Common mistake here is not to remember the plus or minus equations. Right, so those are your final answers. One more problem. So what we've got here is we're looking for the solution to cosine x cosecant squared x plus 3 cosine x is equal to 7 cosine x. This is a problem that I would ask my students to be able to perform. It's an equation I'd ask them to be able to solve on their final exam. All right? So, you want to get this equal to 0, so you'd subtract 7 cosine x on both sides. 7 cosine x on both sides. You end up with cosine x cosecant squared x minus 4 cosine x is 0. All right? I'd ask him to be able to do that. So then, what I'd ask him to be able to see here is that you can factor out a cosine. Each of these terms have cosine in it. If they got stuck, I'd ask them to write a basic algebra equation where wherever you see cosine x, call that x. You see cosecant squared, maybe call that y squared or something like that. Minus 4x is 0. And I'd ask him to be able to solve that by seeing that you can pull out an x. Going off to the side hopefully gives you a little direction on what to do with this slightly more demanding trigonometric equation. You pull out the cosine x, just like you would have pulled out the x over here, and you'd get cosecant squared x minus 4 is equal to 0. You set this cosine x equal to 0. We've done that before. We've solved that problem before. We get x is equal to pi over 2. X is also equal to 3 pi over 2. We've done this earlier in a previous problem using the cosine graph. I'm not going to do that again. Now what we're going to do is we are going to solve this part of our equation. You get cosecant squared x is equal to 4. After you add 4 to both sides, you take the square root of both sides. You get cosecant x is equal to plus or minus 2. Again, that's an error waiting to happen. Be careful. It's a second degree equation. You're going to get 2 solutions. All right, and I took the square root of both sides, adding the positive and negative. So you end up, the reciprocal of cosecant is sine x. Reciprocal of plus or minus 2 is plus or minus half. All right, so sometimes you may not be familiar with the cosecant information about the cosecant characteristic about the cosecant function. So that's why I took the reciprocal of cosecant, which is sine. So by definition, cosecant x is the same thing as 1 over sine x is equal to plus or minus 2. All right, by definition, cosecant is 1 over sine. So what I did was I took the reciprocal of the 1 over sine, which is sine, and then I took the reciprocal of 2 over 1, which is half. Just trying to explain where that came from. So now, you'd have to go off to the side. Sine, your answer is going to be positive and negative, so you end up with an answer in all 4 quadrants because your answers are where sine is positive and negative. All right. So you'd also have to be aware of what the reference angle. All right. So put an x here. The opposite, sine by definition, is the opposite over the hypotenuse. So the opposite is 1, hypotenuse is 2, and that is a reference angle of 30 degrees or pi over 6 radians. So you get pi over 6 here, pi over 6 here, pi over 6 here, pi over 6 here. Another common mistake, as I recall, is sometimes my students have put their reference angle here, or here, or here, or here. Well, those are wrong because a reference angle we've defined as a number of degrees between the angle in question and the x-axis. All right, so you'd put the pi over 6 here because this is an angle between your answer and the x-axis. All right, so it's a possible mistake that I'd want my students to avoid. All right, so the answers would be, coming from this coordinate axis here, would be in addition to pi over 2 and 3 pi over 2, the final 4 answers would be pi over 6. This would be 6 pi over 6 minus pi over 6, or 5 pi over 6. Additional answers would be 6 pi over 6 plus pi over 6, which would be 7 pi over 6. And then this would be 2 pi. Another way to say 2 pi would be 12 pi over 6. Same thing as 12 over 6 is the same thing as 2. You'd go back pi over 6. You'd end up with 11 pi over 6. And these would be, again, 6 solutions that I would expect my solutions to be, I would expect my students to be able to solve this trigonometric equation using the different trigonometric ideas that we just discussed.